You know that Thursday's the day of the test, though, right? So definitely Wednesday, but is Thursday going to help? You can think about it. All right, so we're going to start off with avid notes this morning. I'm going to be using problems from worksheet 5, but because it's several different graphs, what I'm going to do is I'm going to take an avid note sheet, and then I'm going to take one of these, and I'm going to cut these out and put them onto my avid notes, okay? So I'm going to have 2 on each side to save paper. Some of you might like the larger ones, and so you could do 1 on each side. You'll just need 2 papers today, okay? All right, so come up and get what you want, and then I'll be ready to begin in 1 minute.
I got it. Big ones, huh? Big boys, huh?
Oh, and if you guys need more of the 5-5 notes, I don't know why I have so many over here. I've got more of those up here too.
What was that?
The worksheet 5 you mean? Okay, so if you look on that, right there. So the worksheet 5 and then the note down, right there. That's the note, and then right next to it is the. Yeah, they are right there, and then if you need the notes, they're right next to that. Okay, so this is where I'm going to start off with my avid notes today. I have a copy. Oh, it's right here. Wow. All right, so yeah. This is my 5.5. I know there's no 5.4. We're going to have 2 5.5, so I'll put one in the 5.4 spot, one in the 5.5 location. Okay, so I am choosing for my 2 rose curves to use from worksheet 5, numbers 7 and 8. Okay, and my essential question is, how do you graph rose curves? Okay, now several people were absent, so you're going to want to make sure you use this time to learn and ask questions as I go over the problems. Okay, I will be calling on people to participate. It'll be hard for me to remember who was absent and who was not, so I may call on you, so just make sure that you're listening. That way you're not totally lost if I call on you. Okay, so this is what rose curves look like. There are 2 types. There's the sine rose curve. There'll be a coefficient of A, sine, and then there'll be a coefficient called B on the theta. Okay. And then there is the sine curve, the cosine curve. Okay. And we call them rose curves because they look like a flower. Okay. There are a few key things you have to take note of when you are graphing rose curves. I'd make sure you guys are paying attention over there, group 3. A couple of you went to testing without a pass the other day. Okay, or at least one of you. Okay. So there's a few things you need to be aware of, and this part will be the same. And you know how to switch back and forth. Okay, so I'm going to put down, there's only one quiz, right? I already got the quizzes in there, so it's just okay, so you're starting with 3 and 4. And then anybody who doesn't have any 0. And then you go and do 1 and 2. Okay, so it should be 6 for each one. And so some of those things that you've shown before, include missing and typos and stuff. All right, so there's a few things. We need to know the length of the pedal. Okay, length of the pedal. And that comes from the A value. Don't cheat.
Don't cheat. Yeah,
Don't cheat. Hashtag be honest.
Hey, yeah, be honest.
Yeah.
Be honest, don't cheat.
Hey, yeah,
Be honest, don't cheat.
Yeah, once a cheater, always a cheater.
Oh, no.
She took advantage of me.
Oh, no, that's not good.
Yeah, Sam.
Mama, she
All right.
Yeah, I got cheated on this thing.
Uh-oh.
Yeah, it's not good. My ex-girl cheated on me.
Damn, that's not good.
Yeah.
All right. So the first thing we want is the length of the pedal. Anybody remember how we determine the length of the rose pedal?
Hey.
Hey. Anybody remember how we find the length of the pedal? It's the A value. Good. Okay, so, and that's the same for both. So I'm going to put length of pedal. And that's for either option. All right, so Jack G, what's the length of the pedal going to be in example 7?
2.
2, very good. And on the test, there will be a line and it'll say length of pedal. Uh-oh. With a line and you'll have to put 2. Okay? All right, and then I want to know the length of the pedal in number 8. What do you think, Brandon?
1.
It is 1, good, because there is no visible number on the front of the sign function, which means it is implied invisible 1. Perfect. Okay. All right, then we need to determine the number of petals. Anybody remember that part? Number of petals?
Yeah. The B value?
Uh-huh, it has to do with the B value.
It's even double.
Ah, very, very good. So if B is even, then we double it, and if it's odd, what do we do? It is that number, okay? So I'm going to write that down. What?
I taught myself this last night.
Oh, you did?
Yeah.
Perfect. Okay, so I'm writing the number equals B when B is odd, and N equals 2B when B is even. Okay, so I need to know the number of petals for this one. Megan, can you tell me how many petals we're going to have for number 7?
6.
It won't be 6 because 6 is an even number. So it will be 12. All right, and then I need to know the number of petals for this one. Jordanelle, can you tell me how many petals we're going to have for this one?
5.
We are going to have 5. Uh-huh. And how did you know it was 5 and not 10?
Because it's an odd number.
Because it's an odd number.
Yeah, but under N equals B, what 2 words are those?
N equals B when B odd.
B odd, okay.
Okay, then there are a few things that we need to be cautious of. One is different for sine versus cosine, the other is still the same, okay? So, it is the angle from the x-axis, Okay, angle from the x-axis. Does anybody remember how to do that one for sine? You take 90 degrees and you divide by what value? The b value. Okay. So I need to know the angle from the x-axis for number 8. Jason, can you help us with that one?
Yeah, sure.
Okay.
So angle
From the x-axis, yeah.
so it's let's see. Is this sine?
For sine, this one.
So that means it's 90 divided by 5, right?
90 divided by 5, excellent. And 90 divided by 5, what is 90 divided by 5?
You don't, I really don't know.
90 divided by 5.
Like 18? 60 would be 12. So 16 would be 70. 18 would be, what was it? Is it 22? I think it's smaller than 22.
I got 18.
You got 18? Okay, I remember doing my homework and I think it was something like that. I did my homework last night.
She's the best.
I know. Okay, then I need, so the number of petals is the same for this one. Number of petals. Same as sine. Okay. The angle, though, from the x-axis is different. Does anybody remember how to do this one? It is just 0 because it's 0 divided by v, and 0 divided by v will always be 0. Always. Okay, so what is the angle from the x-axis for number 7? Let's just go with Jordan C. Jordan C, what is the angle from the x-axis for number 7?
For 7, it would be 0.
Yes, and how did you know that?
Because it's cosine.
Because it's cosine, perfect. So angle from x-axis, 0 degrees. Perfect. All right, then we need to know the angle between petals. Angle between petals. And this is the same for both. Okay. Does not sound pretty. Okay. Yeah, then you can do one. Got it. Okay, so I need to figure out the angle between the petals. Anybody remember that one? It's 360 divided by the number of petals. Very good. Okay, and that's the same for both. So angle between, same as sine. Okay, the only thing that's different is this part right here, so I'm going to highlight this part so I don't forget. Okay, so I need to know the angle between for number 7. Paolo, can you tell me what the angle between is going to be?
30 degrees.
Very good, and how'd you get that?
360 divided by 12.
So 360 divided by the number of petals was 12, and you got what again?
30 degrees.
30 degrees. Okay, excellent. And then I need the angle between the petals in number 8. Brett, can you help us with that one?
Whoa. Wait, which angle?
The angle between the petals for example 8.
Boom. Boom. The number number of petals are actually my,
Uh-huh.
I can't say that part.
So how many petals do we have in number 8? We have 5. So what am I dividing by 5? Oh man.
Gosh darn it. Brother man.
So what am I dividing by 5?
Divide 360 by 5.
Yes, very good. We're going to divide 360 by 5.
70 degrees for 8 petals.
Perfect, I love it. So 360 divided by the number of petals is going to give me an angle between of 72 degrees. Perfect. Okay, so now I'm gonna, because I'm doing 2 on 1 to save paper, I'm going to draw my sketches on my polar paper resource, and then I'm gonna cut it out and glue it. So hopefully it'll all fit in there. Okay, so I'm going to, for this one, I know that my first petal is starting on the x-axis with a length of 2. Sometimes they are too small, so I am going to scale mine by every other one. So this is going to be 1 and 2, just so it's not so small. Okay, you can change the scale on a graph as long as you label it. So it's 0 degrees from the x-axis, so that's my starting point right here. And then that will be my first petal. And I usually will draw them all with just the radius of that petal first, and then I'll go and draw the pretty petal part after. So then my next angle, I rotate to 30 degrees, so that would be from here to the 30-degree mark, so that would be here. And then between, I take it, yeah, and then it's gonna go 30, 30, 30, 30, 30, all the way around until I get all the way back to the start, okay? So that's 30, 30 plus 30 is 60. 60 plus 30 is 90. Plus 30 is 120. Plus 30 is 150. Plus 30 is 180. Plus 30 is 210. Plus 30, 240. Plus 30, 270. Plus 30, 300. Plus 30, 330. And then I can check if I go another 30, do I get back to start? And I do. Okay? I'm going to put an S here for start. It's where we started. And then when we go all the way back, we loop around. Okay? So it's 30 between each one. You don't have to mark it every time. I'm just doing this for my notes so I kind of remember. And then I want to draw my petals on here. And I like to use a color that kind of contrasts a little bit just so I can see it.
So like the green.
Yeah, the green one probably would have been good.
Pickle red.
Pickle red. Okay, I've never heard of a red pickle, but. Oh, man. And then, so those of you who are absent, you kind of see how we get this flowery looking curve. Okay. Excellent. Okay, so I'm now going to cut mine out and then glue that one into my box, and then we're going to do the graph for the next one. Okay, that will kind of fit. Okay, where's my glue stick? Ah, right in front of me. Yeah. Yeah. Oh man, I just glued my graph to my leg. That's not good. Yeah. Too short. Right? Aren't all weekends always too short?
No. I love
No?
them. They're too long.
They're too long. Oh man. It was good, but I never feel like weekends are long enough.
Yeah, there's only 12 more Mondays.
Really?
Yep.
Why do I hear my voice? Is that my voice that I
I
hear?
doubt that.
There is.
Is someone watching my video?
No, it's less.
Ludwig.
Okay. I hear a voice. Maybe. I don't know. All right, next one, number 8. I'm gonna draw that one here.
Why do you know?
Okay, so my starting petal was at 18 degrees. So I can see that these are marked by pi over 12, and that says 15 there. So 18 is a little more than 15. I can see that these little tally marks are counting by 5, so that would be 20. So 18 should be about in the middle, but I need to mark my radius first. So my radius was 1. So I'm gonna count by 2s. Okay, so here about is where the 18 degrees is gonna be. Hey guys, I'm gonna get really frustrated with you.
Try your best. Try.
This test is gonna be a lot harder than the last one, so you guys might wanna actually pay attention and not be a distraction to your peers. Okay? Alright, and then I see my angle between is 72. So what's 18 plus 72? 90. Perfect. So my second one will be here. Okay, and then 90 plus 72, that's 162. Okay, so I'm gonna mark my little, this was 72. And then it's another 72. So let's see, I said 100 and... I usually block them. That's why I haven't gotten one in a while. Okay, so this is 150. So if I want 162, 55. Wait. 150, 55, 60. I'm getting confused. You guys, I can't think. You're talking so much that I can't even hear my own thoughts in my brain. 180. So 135. That's 150. Correct? 55, 60. So that would be 165. And I want 162.
Yes.
Okay. And then I need another 72. William, what is 162 plus 72?
Wait up, don't do 160 plus 72.
Yeah.
That's 136.
Wait,
No,
236.
236.
236. Okay, so that's 225. So 230, 235. So 236 should be about right here. And then you should see it should be a reflection. Okay. And then I need to rotate again. Okay, wait again. Will, 230. What was it again? 260. 236 plus 72. Can you tell me what that is?
Wait, can you say it again?
Wait, what?
236 plus what?
3. Oh, it's 308. Okay, that number sounds familiar.
What is it?
Yeah, that's
Okay, and then if you do this correctly, you should see that it's a reflection over the y-axis. So this one over the y-axis, it looks like a mirror image. This one over the y-axis, it looks like a mirror image. So you can verify that you did it correctly. And then you can connect with your petals. Okay. Okay. So I'm going to cut this one out and glue it on there. You guys don't need me to do the steps, do you? Save some time. You guys can do your steps. So those of you who were absent, we did do notes 5.4, and we did some avid notes. And then we also worked on worksheet 5 for homework. Okay. A few other things that I might want to add to my notes here would be maybe a little image. So like for my cosine, I know that my first petal is always going to begin on the x-axis. I know that this length here always comes from the A value. Okay. I know that when I rotate, this will be the angle between petals. I usually call it beta. Okay. Angle between, so I'll call that beta. Okay. And then this one is always symmetrical over the x-axis. Okay, and that's just like a little checkpoint.
Why is back there?
Okay. Whereas sine is the more difficult one. Your first petal will be in quadrant 1 because it's 90 divided by the B value. So it's always going to be in quadrant 1. That length there will be A. But you're going to have that extra angle here, theta, which is the angle from the x-axis. Okay, so I'm going to put that one here. Angle from the x-axis. Theta.
Yeah, Miss, you got any dish soap?
Not in my classroom, no.
This is a kitchen, go to banana for that one.
Okay, I'm going to call this one beta, again, for my angle between petals. Okay. Okay, and you guys can do the steps, correct?
I'm trying to think of this.
Okay, I'm going to flip mine over for my next objective. And I'm going to do worksheet 5, numbers 5 and 11. These are cardioid and limaçon curves. Okay, so how do you graph cardioid? And the limaçon has this little accent on it, so it looks kind of funky. I need to look at my, I always do it backwards. Limaçon.
How many 9 of us?
What?
You said stop getting that hydro fast.
I know, it's crazy. Okay, so I think it goes Lima.
Something funny, I'm gonna leave you.
So I think it's kind of like that. I don't remember. Something like that. It's like a C. If you put a C there, it's fine. Curves. So we need to talk about the difference. Their equations look almost identical. Okay. So cardioids have an equation R equals A. You could have an addition or a subtraction sign. You can have a B value, and then you could have sine, or you could have cosine. Uh-oh, I forgot the B. William, I'm going to have to move ya. I can't concentrate with the socializing. I'm having trouble.
Hey, moving. Right now.
Be quiet.
Okay, so I'm gonna write cosine, b cosine theta there in a minute. The limazone looks almost exactly the same. Okay, r equals a plus or minus b sine theta, and r equals a plus or minus b cosine theta. Okay, so the way I'm writing them looks exactly the same. Does anybody remember the difference between the two? One has an inner loop and one doesn't. Very good. Which one has the inner loop? The limazone has the inner loop. And we get the inner loop when? What's the difference between the equations?
The absolute value of b is greater than h.
Yes. Very good. If this value is greater than a, or you can just know if it's not equal to a, okay? But this one here, it's the absolute value of b, so it doesn't matter if it's addition or subtraction. If that value is greater than a, you're going to get an extra piece, okay? The cardioid, they will be identical. So just remember, same, not same. But the process is identical, so you probably won't get messed up. Okay, so let me show you guys the difference. Sine cardioid curves look like this. Like that one. Or like that one. Cosine cardioid curves look like that. Or like that. Limazone have an inner loop. They're almost exactly the same as the cardioids. Okay, so here's what they mean by inner loop. It has this extra little like donut shape in the middle. Good, and same thing for the cosine. Okay. Okay, whenever you have these curves, you're going to end up with x and y intercepts. And so I'm going to draw in my axis, okay? So the x-axis will always touch, I call them the shorter intercepts. Okay, so that's my x-axis. And you can see that you end up with 1, 2, 3 x-intercepts. Okay, 1, 2, 3 x-intercepts. And then the y-intercept, or the y-axis, gives you that reflection line. And so it's exactly symmetrical across the y-axis. I'm not going to answer it because it's an outside number. Another doctor. Leave me a message. Okay. Okay, so you could end up with, you'll always end up with 2 y-intercepts. Okay, technically this one at the origin is both an x and a y-intercept. Okay. Does anybody remember the difference? Like how I figure out what these intercepts are? This is a super easy one. We did a really good, let me grab my notes. Remember those notes we took last time from the lab?
Wait, the values are the right one.
Say it again.
The values are the right one.
One more time.
A values are the right one.
Yes, A values are to the right and left. So this would be positive A, negative A, and 0. This would be negative A, 0, and A, positive A. Very, very good. Okay, and then what about this furthest intercept?
I'm gonna talk. Can I get some water, please?
Yeah.
Thank you.
All right, so how do I find this intercept here?
value times
It is for this one, but it won't be the same for the limazón. So if I want to keep them the same, okay, because it is the exact same for this part, so I'm going to draw in my x and y axes, okay? So this part right here is exactly the same. Negative a, 0, positive a, negative a, 0, positive a, okay? And then we still have this point here and here. This time if I take the b value and double it, it's not going to give me that distance. So if I want a formula that will work for either one, what could I do?
give you absolute value of b.
Absolute value of the b. And then what do I do with that? We're going to do what?
Times 2.
Okay, but if I do that here, absolute value of b times 2 is not going to give me that value for my limazón. It was what? A plus b, very good. Okay. Plus b. Okay. So the only difference here is if it's above the y-axis, this value is positive. If it's below, then
That's my opinion.
all right.
Nobody else will do that.
Yeah, because the bell's gonna ring, huh? Yeah. So let's finish this, okay? I really need you guys to stay focused. So this would be b plus a, but then on this one it will be negative because it's below the x-axis. So that'd be b plus a, but then I make it negative. The only difference with cosine is that the a affects the y-intercepts instead. So this would be a, 0, negative a. This would be a, 0, negative a. Okay, same thing for my limazón. Okay, a, negative a, 0. A, 0, negative a. Okay? So, same thing for these. You're going to add. Okay, same thing. And then I'll talk about the inner loop when we get to that example. Okay, so my first one here, I need to figure out my a and b values. Paolo, what's my a value for number 5? 1. Very good. And what's my b value? 3. Good. And so, b equals 3, a equals 1. Okay, so I need to know what curve is it going to be. Is it going to be a cardioid or a limazón? What is it? Limazón, and that's because the a and b value are not equal. Okay, 3 is greater than 1. So it's limazón. And so I have to figure out which option is it. Is it 1, 2, 3, or 4? What do you guys think? Is it 1, 2, 3, or 4? 3? 1, and nope, because it's not cosine. It's going to be this one. Okay, and so that happens anytime you have a negative. So this would be negative b. This would be plus b. Okay, this one is negative b. This one is plus b. And I can tell because the majority of the sign is on the positive x-axis, on the positive y-axis, and then here the majority of the sine curve is on the negative. And sine is symmetrical about the y-axis. Okay, so I'm going to draw my little predicted curve over here in the corner. Okay. All right, and then I'm going to need to plot those values on my graph. Okay. Okay. So let's see here. I need my x-intercepts. Okay, Jordan C., can you tell me what my x-intercepts are going to be? Uh-oh. Right here?
Positive sign, so it'd be on, 1 on the x-axis,
Mm-hmm. 1 on the x-axis, good.
and then -1.
And then -1 on the x-axis, perfect. And then where's the third one always?
Right on the origin.
Right on the origin, perfect. So on the test, you will be asked to give all the x and y intercepts. So for x-intercepts, you would say -1, 0, and 1. Okay? And then I need my 2 values here and here. Okay? I want this one first. Jack G, can you tell me how to find this one? How do I find the bottom one?
Oh, isn't the -3 value?
I take the 3, but it's not 3. I have to use the 3 to get it. So we have been taking notes over here for how to get that part.
The 3 plus 1?
It is 3 plus 1. Very good. And then I need to make sure that I put it below the axis. So I'd go my absolute value of 3. I'm adding the 1, but then that value needs to be negative because it's below the x-axis. And so 3 plus 1 is 4, so I need a 1 at -4. Okay, I'm counting by 2, so 1, 2, 3, 4. Okay, and then I need this one for the inner loop. Okay, and then that one's what? 3 minus 1, very good. So I take my absolute value 3, and I subtract the 1, which will give me -2. You too.
Thank you.
Okay. I'll try it. I'll reassign it next time. It's just going backwards, writing the equation. Alright. Hello. Okay, so I'm gonna glue that one right there. Okay, and I did video myself doing the other problem if you guys want to see that one. Or if we need to review it real quick tomorrow.
Yeah. Okay. My question.
I have some that's like really thick, so we're like touching it. Xavier, can you tell me what type of curve this one's gonna be?
Wouldn't this be a cardioid?
It is a cardioid. How did you know?
Since A and B are equal to each other.
Mm-hmm. Very good. Cardioid. Because A is equal to B. Okay. And our A here is 3. And our B here is also 3. Very, very good. Okay. So cardioids have a very similar shape to limosome with just a subtle difference. So cosine will look, or sine will look like this. And cosine will look just like these ones except no inner loop. Ah! Going into our garbage? Nope. Thank goodness. Do not want to dig in the garbage today. Okay. And then this one. Okay. So I need to figure out which one of these patterns I'm looking for. What do we think? Austin, can you tell me which one? Which one of these would it be? Top left, top right, bottom left,
I think it's bottom left,
bottom left. Why? You're correct.
just, because the addition sign plus the cosine, which means it's gonna be going that way.
Perfect. Okay, so here the addition sign means that it's where most of cosine curves are positive, which is in quadrants 1 and 4. So the bigger part of the cardioid needs to be in those two quadrants. Very, very good. Okay, I am going to be asking you again, what are the x and y intercepts? On the test, it'll just be like one line. You're going to have to know that there are 2 to 3. Okay? I could put 3 lines, but then you're going to look for 3 every time, right? Yeah. Okay, so if I put 1 line, does that indicate that it could be multiple?
Yes.
Okay, so I need to figure out what those intercepts are and then graph them. Okay, so let's see here. Austin, can you help me figure this out? What are the x-intercepts going to be?
I have no idea.
Okay, so let's go back and review our 5.5 notes. Over here. 5.5 notes we took last.
Wouldn't that be 5.4 then?
No, I don't think we have 5.4 notes.
Yeah, we do.
Yeah, we do.
We do?
Yeah, we just got 5.5 today.
Oh, that's what I mean then. 5 point, dang,
Ooh.
they're just all numbered wrong. 5.5 should say 5.6.
Yeah, this is 5.4.
All right, so the ones that say 5.4 are actually 5.5.
And what's 5.4?
5.4 was the polar lab.
Mm.
That was just a.
Yeah, it was just that investigation that you guys did.
So 3, 0.
Hmm? All right, Austin, you think you got it?
Yeah.
Okay, so what are my intercepts going to be?
Well, the x-intercept's gonna be 3, 0, and negative 3.
3, 0, and negative 3?
Because the, how's that one?
Oh, that's why? So you know
You got 1.5.
So negative 3, 0, and 3 for the y-intercept. Yeah, because I want that a value here is going to tell me what these ones are, right? So that's for the a. Okay, so I'm going to plot those. 1, 2, 3. I'm going to put a positive 3 there. 0, 1, 2, 3, negative 3. Very good. Okay. And then what are the other intercepts going to be?
Are you still asking me?
Mm-hmm.
Oh. I'm still working it out.
Isn't this where you like the absolute value of B,
Yeah,
B
absolutely.
plus?
B plus.
Yeah. So I take my B, which is 3, and then I add the A, which is 3, and what do I get when I add those?
6.
6. Good. So when I add them, I get 6. Am I supposed to put it as a positive 6 or a negative 6? Positive because of this plus sign right here. Okay? So I'm going to put plus. It's always going to be on the positive axis if it's a positive here. Okay? So I like that a lot. So I'm going to do 6. 1, 2, 3, 4, 5, 6. Okay? And then, did you say there was another one? There is one more.
Oh, is
Zero.
It is 0. Good.
3 minus 3?
Yeah, I want you to write it down. You don't have to plot it again.
Wait, why would. Wait. Did we multiply the 3 by 2?
No, you add the 3 plus 3.
Yeah. It's
Uh-huh.
To get
absolute
that.
value G.
So only for the petals we multiply. Wait.
Only for even petals do we multiply by 2.
Yeah. Okay.
Got it. Okay, so I'm going to connect mine now. Okay? And then I'm going to cut mine out and glue it. Okay, do I need to do the steps with you? Or can you guys go back and write your steps in.
Help.
You want help? Okay. Yeah.
Are we going to do like more stuff after this?
Not really. We're gonna write equations. All we're gonna do is go from this to then the equation.
Okay.
So it's not really anything new. But we haven't quite done that before. It's super easy.
Yeah.
It's way easier than the graphing part,
That would be
I think.
I think this is a lot easier than graphing.
okay.
Oh, you mean writing equations?
Yeah, I mean like the writing thing part better.
Okay. So, whenever you have something of this form, okay? So, my first step is determine the type of, I was going to say polar graph, and I wrote graph first. The type of polar graph. This is going to say polar,
I know.
or polar equation, either way, okay? And I have some tips on how I remember. So if it's something like R equals A sine B theta, or R equals A cosine B theta, then these two are Rose curves. If I see something like R equals A plus or minus B, sine theta, or R equals A plus or minus B cosine theta, I have two options, okay? I have the option where A equals B, gives me the cardioid, and where A does not equal B, and that's our limaçon. Okay. Then I'm going to follow steps for cardioid and limaçon because their steps really are the same. You can do them exactly the same because the only difference is this inner loop. And the inner loop, if I were to use that same step where I take the B minus A, 3 minus 3 is 0, which is giving me a non-existent inner loop, or an inner loop with distance of 0. So I'm going to write, I like to draw a basic sketch, okay? Or predict what the graph is going to look like. And I do this in all graphing problems. I always do a little prediction. Predict what the graph will look like. And I didn't write down that prediction here, but I'm going to do that right now. So my prediction was, okay, because A equals B, okay, and because it's cosine, okay, I knew that it was going to be, and then because it was A plus B, I knew that I was going to have the majority of my curve on this axis here. And that my inner loop would go away. So that's like my little thought bubble. Okay, and I like to write it down because sometimes I'll be working and then all of a sudden I'll do a rose curve or something ridiculous, because sometimes I literally will forget what I'm doing in the middle of the problem, especially if I get a text from someone or, when I'm doing homework or whatever. And then on the test, who knows, okay? And then in this one, this was my little thought bubble. Okay. Okay, so that's my prediction. Hi.
Could we have Anna O'Mara? Is she here?
She's here.
I can talk to you for. Can you please have a minute with her?
No problem.
I know.
Okay, so we want to find A plus B and A minus B. Okay.
Yeah. Can I borrow your whiteout? Yes, I actually calculated it. It's not loading there.
Robotics. Oh, here it is.
Yay.
Yay.
Thank you.
So calculate A plus B and A, oh, I guess it should be B plus A and B minus A. Yeah, and so I'm gonna do B minus A. Okay, I'm gonna erase this extra A. Okay, and then you need to determine if the intercepts need to be positive or negative. Okay.
Well, we were just in the crossbucket.
And I'm gonna write refer to prediction because I'm very visual, and so if I turn this into a bunch of words, I'm not gonna remember. Okay, so I know that this is a positive intercept, a positive intercept, 0, and a negative intercept. I also remember that these shorter ones come from the A, and this longer one comes from the B plus A. And then I kind of wrote that one here. Okay. And then I substitute my values in for A and B. I mean, then I plot them and connect with the predicted curve. Okay? Is that kind of okay? Okay, so I'm gonna ask you guys if we need to have 1 or 2. Do we need 2 examples for the rose curves, or should we just do the hardest one? Let's do the hardest one. Okay, so the hardest one, in my opinion, is number, I said 9. Is that correct?
I have no clue.
No.
I know.
Okay, the one on the test may have a 5 or 7 or something like that, but it'll be
Oh,
very
that's
similar.
ridiculous.